Hi everyone. Glad to see all of you here. I've been working in the past 2 or 3 weeks together with another colleague of mine, Eagle, that today is not here, on the Python SDK. We saw that so many people were asking for this, and we just cracked it and did it. So today I'm gonna show a little bit of an example of how things are going. We have released the first 0.1 version, which I'm gonna show you about. You can already start working with and playing with. So first of all, I want to show you very quickly how you can get started with the Python SDK. So we have an example that you can download either from our examples repo that is available at Restate examples, or you can just use the CLI. So you do Restate examples, and here you can choose the programming language. We choose Python, and then we get our hello world. And then you can see here there is a README that tells you the next things to do. So you need to do the virtual environment, activate the virtual environment, install the requirements, and then you can start. And this example is a very simple, very minimal example with an hello world. Okay, so right now I want to show you a more concrete example. There's a ticket reservation example that is an example where we have three services. For all of you that doesn't know what a Restate service or virtual object is, a service is a container of different durable functions. And a virtual object is an extension of a service that can also hold some state. And those two primitives are very powerful for modeling many applications of different types. In this case, we want to build a very simple ticket reservation system where a user has a cart with the different tickets he wants to buy. And then there is a ticket a store where we have the status for each individual seat of, let's say, the theater. So, for example, whether a seat is reserved or is not reserved, or whether it's available or not available. And then after the user clicks on the checkout button, we want to start a checkout flow that executes the payment. And then after that, sends a success or a failure email. Now,
maybe some of you who have done the tour of Restate recognize this example because it's the Python version of the tour of Restate that we already had for the other languages.
So let's start first with the cart object. So let's say a user wants to buy a ticket. What it does is that it sends a request to the cart virtual object. When doing so, the flow is that we will try first to check with the ticket service if there is an available seat. If there is, then we store in the state of the cart the ticket that we just reserved, and then we schedule an expiration in case after 15 minutes the user won't do anything. In the ticket reservation, we store a variable inside the ticket virtual object saying whether the status is available or not available. After we have reserved the tickets, we will have a list of tickets as a state of our virtual object. We will trigger the checkout. And when doing so, we read the tickets that the user reserved so far. And then after that, we will do a call to the checkout service, which will process the checkout. The checkout service will essentially execute the payment, invoking an external service, for example, Stripe, that executes the payment. And then after that, we send an email, depending on whether there was success or failure. Now, we put everything together and we bundle this in a single app. A restate.app creates the final endpoint that Restate will hit every time it needs to process a request. Now, something interesting to say here is that the SDK is built on top of ASGI. So for who of you that is familiar with Python, ASGI is this specification for HTTP services. So there are different services you can pick from as a basis server for HTTP, and then on top you execute an SGI application. And the Restate SDK will expose itself as a ASGI application that you can execute on one of those servers. So first of all, we need to do the Python virtual environment thing. So we do the virtual environment, we activate it, and then we store the requirements. This is business as usual. So now we're ready to start the application. So we do Python 3 as a server. In my case, I use Hypercorn. That is one of the most advanced right now ASGI servers. There are other, but this one is so far the one we tried, we tested, and it works very well. And with this, we now start our services. Now we can start Restate. So we call Restate server. And we started the Restate server. And now we register the Restate service. When doing so, we essentially say to Restate, this is where you can find those services. So Restate TP, register, and there you go. And when we register, it will tell us what are the services, virtual objects that will be added. And you see checkout, cart, and ticket. We register, and now we're ready to send the first request. So let's first try serving a ticket. Curl, post, okay, and we add the ticket. Now,
could you explain a bit what the curl commands here represent?
Yeah. With the curl command, we will essentially add the ticket to the Mary cart, serve a seat. With this, we essentially executed the code here to add the ticket. And now we will have inside the virtual object cart, we will have the tickets variable filled in with this ticket ID that is a seat2c. Now, actually, this service does not have any way to access to read what are the available tickets. So let's add an handler for doing that. For doing that, for add a new handler, we simply do cart.handler, and then we define the function. Let's say we call this list of tickets, and then we need to pass the context object. This one won't take anything, but will return a list of string. Actually, list is like this. Yeah,
maybe a small clarification for those who didn't work yet much with Restate. What is this object context?
This object context is the way you can actually access all the features of Restate. So you will see this now here for getting the tickets. What I do, instead I do await context.get, and here you see actually all the different features that you can access for a virtual object. So you can access clear the state, clear all the state. You can access the key of this virtual object. You can get state, and so on and so forth. You can set state, and you can do calls to other services. In this case, we want to just get what are the available tickets. In case there is nothing, we just return empty value, and then we return the tickets. Now, to start this, we do the following. We start the server, we start it, and then we need to register the service again. We need to register the service again to tell Restate that there is a new handler that we can call. So we will do Restate. Okay, and this command is going to tell me, look, you're adding a new handler that is called the list tickets to the virtual object cart. We apply those changes, and then we do curl. Now, just list tickets. And this tells me that indeed seat2c was stored previously when I did add ticket. So I can also add another ticket as an example. Let's say seat2c. And then this ticket will tell me this seat2c and seat2b are in the cart, are in the Mary cart. Now let's try to actually perform the checkout. So we will invoke the method where it is checkout here. And this will again read the tickets, invoke the checkout flow.
There is one question from a user who noticed that the revision increased for all the services, but that we didn't technically update all of them.
Yes. So right now, the way revisions work is that Restate assigns a new number every time it sees a new endpoint. And an endpoint is a collection of services. So even though the other services were not updated, Restate treats them as updated. Because effectively, Restate does not know until it runs the code whether the service code, so it's like if you, for example, reordered this operation, with this operation, Restate won't know this until it actually executes that code. So that's why it applies every time a new revision, even though it just doesn't know whether there's something new or not. So the revision is something that has to do with both the interface, so the enders that you have, but also with the actual code. Does that answer the question?
Yes, Omar let us know that the question is answered.
Okay, cool. So yeah, so let's inbox this checkout. Just again another curl command to execute the checkout. And yes, you see here we logged. Okay, we logged that we did the payment successfully, and we charged the 80 cents. I don't know how much it is. After that, we sent an email to Mary to specify that the payment succeeded. Okay, so this is the example that we have built at the moment. We are still working heavily on the APIs. So what you see now might change in some ways. And we are now working on making this feature complete with the other SDKs that we have, TypeScript and Java.
Maybe one question related to where we are. So this SDK is now version 0.1, I think. What does that imply for the stability of the SDK if I would want to use it?
Yeah, so 0.1. So first of all, 0.1 is the SDK. This means that effectively this has nothing to do with the stability of the runtime. The runtime today is stable, and the runtime is the one that dictates the correctness of the application, which means that the Python SDK might have some bugs because it's 0.1. It still means that actually your application is correct, and that the runtime will enforce the correctness. The SDKs are effectively at the end APIs to interact with the runtime. 0.1 means that we might probably change the APIs, most likely. We also are looking for feedback. And yeah, we look forward to have more engagement from the community to actually work together towards a more stable API. What is missing right now is that, well, we miss that there are still some features that we actually miss that are very important for us. The Lambda support is something that actually we'll try to work do this week. And actually, that's pretty much it. Right now, we hammered down a couple of features in there last week. So, yeah. Actually, something interesting to say that so a couple of interesting bits about the Python SDK is that so inside it is built with a Rust core. So we worked with this Rust core that we hope to apply to other future SDKs as well, maybe even to the existing ones. And another interesting thing is that both Python and also Golang, we already test them with our internal fuzzy testing tool. So in terms of correctness, it should be both fine. There's probably room for improvement in different directions, like performance, API-wise, but definitely in terms of correctness, they should not be in a good direction.